All right, welcome to Foundations of Math 30. This is FM30.07. We're going to be looking at understanding and representing functions. So we're going to separate this outcome into three different parts. Part A is going to be polynomial functions, and then within each part, we're going to look at the general equations and the characteristics of the graphs. And then we're also going to be looking at determining when I have data, what kind of function fits, finding those equations, and answering questions surrounding real world data. So as I said, we're going to be looking at polynomial functions, including linear, quadratic, and cubic. Then we will move on to exponential, logarithmic, and sinusoidal. So this lesson specifically will be about linear functions. So we're going to be going all the way back to Foundations in Pre-Cal 10, where you looked extensively at linear functions. And here's a quick review of what you learned. Essentially, a linear function has a degree of 0 in the case of a horizontal or a vertical line, but most often a degree of 1, which happens whenever you have an oblique line. So oblique means like a slanted line. Remember that what degree means is the highest exponent on the variable. So when you have equations of linear functions, what you see are both the x, you have to have a y, and you have to have an x, and both of them have exponents of 1. So these are all examples of linear functions. What we call the parent function for a linear equation is y is equal to x. And when we graph y is equal to x, it is a line passing through the origin that has a slope of 1. So rise 1, run 1, and it is increasing as we go left to right. Remember that when we have a Cartesian plane, we have their quadrants. So quadrant 1 is where everything is positive, and we go counterclockwise around. So 1, 2, 3, and 4. These are named using Roman numerals. However, if you want to just use 1, 2, 3, 4, I'm totally cool with that. Okay. The one new thing here that we're going to learn is we're going to discuss end behavior, and we're going to be looking at that often throughout this outcome, the end behavior. So what that means is that we read a graph like we read a book. We go left to right. So this linear function, the y equals x, begins in quadrant 3. Okay, keeping in mind if this is 1, 2, 3, and 4. So it begins in quadrant 3 and it ends in quadrant 1. So when you read it left to right, this goes from quadrant 3 to quadrant 1. That's called the end behavior. Okay, some a common linear function that you might be used to is the equation y is equal to mx plus b. So remember that m is the slope, so m is the slope, and b is the y-intercept, and that's maybe the most common formula that you are used to. So what we know is that the b value, the number being added to y is equal to x or subtracted, shifts that line up and down, and the m, or the slope, changes the steepness of that line. Okay, so remember that we have domain and range. So domain is all of the x values, range is all of the y values. Okay, so for any linear function, an oblique line, the domain is all real numbers, because we know that we can continue, like this line up here would have arrows on either end, so it continues in both directions in the x direction forever. And the range is y as an element of the reals, because it goes up and down forever. Remember that we can use function notation. So all function notation is you replace the y with f of x. So if I had the equation that said y is equal to 2x plus 3, if I wanted to put that into function notation, it would just say f of x is equal to 2x plus 3. Okay, so what you're going to do, and what you'll be looking at kind of throughout this whole unit, is you'll have a little blurb, and then there'll be some graphs for you to graph, and you will fill in the chart with everything. Okay, so you can always do a table of values, but if you remember that it is y is equal to mx plus b, that's the most useful, maybe, form of the equation, sorry. So in this equation right here, we have a slope of 2/3 and a y-intercept of -5. So you start by plotting where that y-intercept is, and then from there you do your slope, so up 2/3. And I would do that again. Usually I do that until the end of my graph paper. Then you take a ruler, please take a ruler and a pencil, I would definitely encourage you to work in pencil on these guys. And you're going to draw a line through your points that you've plotted. Remember to put arrows on either end. Okay, so then we want to talk about the end behavior of this. So again, when I read this left to right, it starts over here in quadrant 3. And remember that this is going to go up here, so it would go into quadrant number 1. So quadrant 3 to quadrant 1. The domain of this is that x is all real numbers, and the range is that y is all real numbers. Okay, so I want you to go ahead and complete the rest of these. You may need to solve for y. So for example, in this next one, I'll maybe just go quickly through. So you would have 2x plus 3y minus 6 equals 0. So you want to leave the term containing y, move the 2x and the 6 over, so you would subtract 2x and add 6. So we would get 3y equals negative 2x plus 6. Then divide by 3 every single term, and we get y equals negative 2/3 x plus 2. So then I have my slope and my y-intercept, okay? So slope is the number in front of the x. The y-intercept is the number that's all by itself. So you go ahead and fill in the remainder of these graphs, and then you can move on to talking about quadratics.